Let's solve this further math mechanics question together. The distance x in meters of a moving particle at any time t seconds is given by x equal to 4t minus t raised to the power 3 divided by 3 plus 9. We have to find a, time, b, the distance traveled when the particle is momentarily at rest. Okay, we have to get the time and the distance traveled when the particle is momentarily at rest. Okay, this is why question. Now, this is what we are going to do. We are given the expression for the distance. We are going to write it out. We have x equal to 4t minus t raised to the power 3 divided by 3 plus 9. Okay, there's a key point here. They said you have to find the time and distance traveled when the particle is momentarily at rest. When the particle is momentarily at rest, the velocity is always equal to 0. So how do we get the velocity? Expression for the velocity. So the expression for the velocity, we can get it from the distance by differentiating the distance. Okay, the differentiation of the distance, that is the x dt, is going to give us velocity, and differentiation of 4t will give us 4, while differentiation of minus t raised to the power 3 divided by 3 will give us minus 3t squared divided by 3, and differentiation of 9, which is a constant, give us 0. So velocity is going to be 4 minus t squared, because 3 is going to cancel 3. Okay, now let's do a quick recap on differentiation. If I have to differentiate a x raised to the power n, okay, so if y equal to a x raised to the power n, the y, the x, must be equal to a multiplied by n multiplied by x raised to the power n minus 1. So what you are going to do, you multiply the coefficient by the power, then you subtract 1 from the what? From the power. So now, for example, like that 40, so differentiation of 40 with respect to x, that will be dx dt will now be equal to 4 multiplied by 1, because the power here is 1. Okay, t raised to the power 1 is equal as t. Then multiply by t raised to the power 1 minus 1. So that will give us 4t raised to the power 0. And t raised to the power 0 is 1. So that will give us 4 times 1, and that is 4. So differentiation of 40 is now 4. The same thing applicable to minus 3t raised to the power 3. We multiply 3 by the coefficient of t here, which is minus 1 over 3. Okay, that will now be minus 3t squared divided by 3. 3 is going to cancel 3, then we have t squared. So ds dt is velocity, which is now 4 minus t squared. Again, when the particle is momentarily at rest. When the particle is momentarily at rest, the velocity must be equal to 0. So this expression, we are going to equate it to 0. So that is going to be equal to 4 minus t squared. Okay, so we can now determine the value of t. So t squared will give us 4. T will now be equal to square root of 4, and t equal to 2. So the time when the particle is momentarily at rest is now equal to 2. Now let's determine the distance covered. The distance covered, we just substitute the value of t equal to 2 in this expression. So the expression is x equal to 4t minus 3 raised to the power 3 divided by 3 plus 9. The distance will now be 4 multiplied by 2 minus 2 raised to the power of 3 divided by 3 plus 9. So that gives us 8 minus 8 divided by 3 plus 9. 4 times 2 will give us 8. 2 raised to the power of 3 is 8. Then over 1, then we can now determine the XCM. The XCM is going to be 3. The XCM of 1, 3, and 1 is 3. 1 in 3 is going to give us 3. 3 multiplied by 8 is 24. Minus 3 in 3 is 1. Multiplied by 8, that will give us 8. Plus 1 in 3, that is 3. Multiplied by 9, that will give us 27. So we can now add 24 to 27, then subtract 8 to 8. That will give us 43 divided by 3. And 43 divided by 3 is going to give us 14.333, which is approximately 14.3 meters. So the distance traveled when the particle is momentarily at rest is now 14.3 meters. Now take note, anytime you are giving distance and you want to determine the velocity, you have to differentiate the distance to get velocity. Yes, the t, okay, the differentiation of our distance always give us velocity. Thank you very much.